Hello, I'm Gareth, and I each week stream to attempt to learn about different things. On this, in this session, I'll spend some time learning more about CUDA from NVIDIA, which sort of lives on top of the NVIDIA stack of tools. Part of the reason why I really wanted to do this is that I really wanted to learn a little bit more, as a lot of the sessions I've done have been like pretty high level. This one's is hopefully going to get more close to the bare metal, and we'll hopefully learn more about sort of some of the low level things that we can do close to the hardware. So on this one, we'll hopefully at the end of this have some learnings to take away that we can use that that we have used that we can take away from this. That I think will be interesting. I'll try and time cap it at an hour or so, depending on how things go, and spend some time on this one. All right, I want to jump over to this computer, and we'll get an A100 fired up. All right, back in 5. Let's go ahead and get started. Let's clear this. So I'm going to open a folder called dev CUDA launch CUDA test. All right. And we should have a folder here. Okay. Now we can finally get cooking. Okay, so we're going to call this test.cu. Use some of this code. So it seems like this does what? Hello from the block ID and thread ID. And to run this, I can run this with. Can you see this? Probably not. We'll do NVCC test CU output test. There's a lot to do with tests. I know. I need to like build it first, then test it. Sweet. All right. So let's do a vector addition. Call this vector. Vector dot vec add dot cu. Go through the same process, I think. Okay. No, wait, just starting to like understand this. So let's. Whoa. Visual Studio Code. Wonderful. We'll do MVCC vec add output vec add, and then run this. I'll just get result. Okay, so it does something here. Let's go ahead and add codecs to this. Codecs, no extensions. No, this is not the right codecs. Wow, that could have been bad. How did they not fix this? All right, now we got codecs. It's slightly confusing because I don't know whether it is what project it's in. If that makes any sense. Let's get this wider. Okay, so it does. Okay, sweet. I was just making sure that was in the right directory. Let's do ask. What is going on in vec.co? The programming the Puppet CUDA vector edition. Okay. Well, I just want so it runs on the global. It runs on the GPU. Each thread gets a unique global index via block X. Threads inside a block share block IDEX, but differ thread X and block dim. Regular C++ code on the CPU, host memory, malloc. This does the free up. Here's 256 threads, blocks in a common to cover all elements. Focus on writing kernels. Okay, let's write a kernel. No, help me understand CUDA more holistically, starting with kernels and assume I'm coming. You'll get this webcam to work eventually. Let's see. Kernel's the core idea. It's a function that runs on the GPU in many threads at once. In Python, imagine. And then you have a parallel map that runs in parallel of all the elements. Good example conceptually. Like a function you past a parallel map. Okay. In C++, with CUDA, this would look like this. Okay. Understanding kernels in plain English. Let's proceed to implement a kernel, but keep it simple. You want to create an array of n. What the? Create an array. We'll do the same for loop. We'll press by many GPUs. Each thread will handle one index. Okay. And we'll call this fail indices.cu. Then okay, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. Okay, so it just has an array size small so that it allocates the host memory, allocates device, how to compile, understanding the kernel key part. Let's unpack using. Imagine you want to do this on the GPU instead of a for loop. You can say launch many threads, each threads gets its own index and does an array. Think of it as Python analogy is if. Okay. Allocate CPU memory, allocate GPU memory. D is the device. Okay. Decide on threads and blocks, threads. What you should take away from this example. Do something with the I. Okay, so let's come up with someone. Can you help me do something with the I here? I think what I'm not understanding is how many block idx.x times block dim x plus thread idx is exactly. Many threads are grouped into blocks. When I scroll up, it goes the other way. So strange. Yeah, okay, I understand that, but like, see on the smaller was for each everything in a block. Okay, so it does the work of its own index. you don't need many threads or the GPU. I understand that, but the okay. So when you have the same operation over multiple times, okay, okay. So what about let's just do math operations? Yeah, I get that. Okay. So it's about multiplications that these GPUs are good at. Okay. Can you come up with a practical example with a data set from Hugging Face? And thing with CUDA. So I'll need some C++ code to do the math training or something. Yeah, so that's this main function. This runs on the CPU, and then this runs on the GPU. So it just like sends the data through. Interesting. And there's like some copying and pasting of the data back and forth. I did learn that the GPUs are just like really good at doing complex math. It's pretty obvious. Okay. So we're gonna load the data from Hugging Face. Get imdb.ipyb. No, it's look at this with that generate code. Try to be everywhere. Okay, let's. Let's load. Install these dependencies, and then hopefully we get. So since I'm going to prepare the data, then we're going to train on this data. Okay, so it's done. Please update. Okay, so now we have these bin files from here. What did this just do? Oh, so it's saving them as binary. Turns the text, loads the data file, produces this text. Let me just make sure what the labels are. So the first 10 labels. What? No labels, texts. Okay, so it's got some like degree of text in here. The text is turned into like a bag of words, and then they're vectorized, and then they're put into some shape. Okay, so that makes more sense. Okay, this is a lot, so I want to know what this does. So we're going to call this train log regression. Train log reg. Whoa. Train log reg. .cu. Come on. We don't like that. Okay, read the binary things and the floats. Read the binary ints. Each thread handles one sample. Each thread handles one feature. Then there's some training. Help me distill down what is going on in train logreg.cu. So if I was to run this, I always say that. I don't know why. Train logreg.cu output train. Oh no. Yeah, well, maybe I know what. I specify the output. Just the so that if I train logreg, it's gonna like produce this like output. Okay. So we did we did this. It can help me understand. Where's the forward pass? One's 24. No. Don't think for a while. This sort of training loop, it would look like the training loop, the gradients. Data is just raw pointers instead of numpy arrays. Okay, so we just did that. One CPU thread is one training example. XI points to, because XI is a flex ID. Okay, Python equivalent to the whole kernel. Compute gradient. One thread equals one feature. It loops through the examples. Python equivalent is this gradient. Python analogy. Okay, allocates memory, copies the data. Then there's a training loop. So for each one, forward an error on GPU. Then it does this synchronize. Finally, on the CPU, produce the output. Okay. We're just asking the same model of the same thing. Build a simple evaluation pipeline. We have to wait onto the GPU to avoid repeated host device maps. Let's implement this. Right now, only writes one database. Let's change it to the training data set fit on the training set, train both sets. Let's change this. Let's do something useful with the data, e.g. predictions or something like that. Don't have to keep using a BIMDB database. Maybe something else. Let's build it again. How did to accumulate the bias and cross empathy loss directly on the GPU shared instance is one that needs to come about the whole our update the training loop. Okay, let's go get this then. This is going to do some prediction on house prices. House price. Let's just keep using this. It's easier. So this loads the data, gets bedrooms, location, and area. Build a simple processing pipeline, numeric area, bedrooms, location. Then it saves it in a binary format, saves the processing data. Okay. Now we're going to use some linear regression. We minimize. Let's just this is gonna. Let's see. Train house regression. Let's see you. Beats the gradients. Train house regression. Did not do any of the predictions. Let's just ask codex. Let's just add a new task. Can you fix the train house regression.cu? And then after, let me know what happened. So this need to just lower the training rate. Kind of interesting. It's super cool. Rainbow CSV, no thank you. What's it, bro? I think we get lost is the question. I'm sure if I should just use Claude Code instead here too. Uh, wow, it really wants everything in its context. GPT loves to think. It doesn't really like to do at times. It's just kind of frustrating. How long have I been at this for? Okay, not that long. For some reason, like I was doing this for like an hour or something. I was like, this is this is a crazy long time. Uh, okay. This is, I just want to know if it's going to fix it. I guess while it does that, let's go work on something else. New file. Actually create a folder. Soccer predictions. Right. Soccer. Okay, hold up high. Oh, so it wants me to download it? What the? From download it, download SQL. 2,500 matches between 2008 and 2016. over the wire, so it should be fish. Codex finish. It definitely it moves to Python so quickly. I understand that it's probably trained on that data, but it's kind of interesting. With that, it's finished. So let's download it. It's not fun out. CD soccer. Database malformed. Wonderful. It's so much more handy to have things on your machine. Can I run something else while this runs? We'll fix this in operations. One sec. These are really good. So this one's still going. So I'm still trying to optimize around the use case. It's funny how I default to going straight to the coding agents for help. Um, yeah, it's so interesting. Let's see. These things are running all these things. Let's see. Let's go back. Okay, so this one. Place the corrupted RAM successfully. Well, verify the new binaries and you can charge them. Blah, blah, blah. Okay, so it did the work to fix this. Now, I'm going to train the soccer scores. So let's take the soccer scores. This would be so much easier to view. I'll ask the question later. Train soccer softmax CU. Put this way in here. And then I need to run it. I need to run the. Okay, the test accuracy is like. Test accuracy is like this. How do I improve it? This is safely and use C++ with CUDA. So some data more advanced training here. Okay. Okay. The CPU, did it actually fix it? Because that's wild if it did. That's sick. So it like predicted house prices on that data. It's wild. I mean, if you have like lots of complicated, if you have math to do, like, why would you, in a case to use the GPU just makes so much sense. I guess it's going to figure this out. I'll be back in 1 sec. I realized you can't even see me. There you go. Flip this around slightly. So there's like one part of it is like training that we learned about, which is like, okay, you like kind of produce something that produces some weights. And then there's like inference is another. So I'm trying to learn a little bit more about inference. Players. Acute emphasis, why linear layer? So it loads the weights, takes the new input data. The kernel is just a function that runs in parallel. Okay. The kernel uses the input weights to compute the outputs, copy the predictions back to you, print them, send as well, serve from okay. A tiny mental model for a singular linear neutron is the predictions is the weights plus by what a great name for a company. GPU put run a kernel that does this. Load the weights from the disk into the CPU. Allocate the GPU and copy the weights once. Copy the inputs from the batch. Launch the kernel, compute the outputs. How big models do it conceptually? Even bigger than just a bunch of these other linear layers, activations, convolutions, inference chains, them like layer 1, activation, layer 2. Yeah. Yeah, let's see inference. This just is like going on it. It just like keeps going. I don't understand how you would do this on a bigger on a really large data set though. Yeah, see, because this just has the same results. That's a simple inference. Find the tiny model data on the GPU, number of samples, number of features, land weights, just these hard-coded things. So all the predictions from the GPU, allocate the GPU memory, and I assume this is copied back. Copy the inputs and weights to the GPU, launch the kernel interface, wait for the GPU to finish, copy the directions back to the CPU, print the results back. Interesting. So let's create one in here. Definitely need a lot of data to do this. Let's move this out. Simple inference dot cu. Okay. Let's compile it. Doesn't like that. Oh no. Inference, and you should get something like this. So it's like, here's the predicted, and then it converts those, I guess, on the other side from the vectorized integers for the text, and does this like prediction. Huh. Still going. What's one thing which I'm impressed with is this is not the usual time. I think that'll actually improve the model. Can you improve inference, simple inference.cu and add rectified? It's a common activation using neural networks. If X is positive, keep it. If X is 0, okay. Yeah, but I did this before when I was like training a model. When I was training a model, and it like removed zeros. I think I should probably go do the GPT thing again. I think that would be a fun thing to revisit because it has all the activation layers and does this, and then we do softmax on the value. Like I think it's like a good use of time to learn more about it. Okay, so this is thinking and doing this work. Did we finish this? No. I wonder how good it can get. That's what I'm wondering. Is like, how complex is this thing now? Whoa, that looks way better. Let's see. It's now 400 lines of, and it's like hard. Like you got to spend a lot of time trying to read this. So it does Atom. There's some hyperparameters. There's a network. Not messing around. Considering adjustments. What did I ask it? You just have to be patient with it, right? It's like, okay, so it's like this. Analyzing CUDA files. There's a missing GPU. Okay. Well, I just ran it. Unless we get you different from yours, but the structure is the same. With an example, we can say weights. Still going. I mean, how good is it going to get? That's what I would like to know. What's in this file? Predictions. Okay, let's do this. Let's go to inference and they have to fix Git as I do this. Like you're running like two agents at the same time on the same code base. It's like you need work trees in order to do this properly. I'm not sure how far work trees would go with this, but this needs to work with work trees and like somehow be set up in a way that's easy to work with those work trees. This thing has been going for ages. That's hallucinated. Mm. Okay, just let's go back to soccer and see commit the regenerate button if you want to push the accuracy even further experiment. Yes, it says tests. I did Richard Botmark and rewrote the trainer into a CPU-based add-on logistic, lift the accuracy. What was the accuracy on what was done? What was it? It was like Hugging Face, Soccer. I'm curious, like this was the source. It was like all these things that people did. Was there like some like result that did is like a competition or something? Is this cool though? Does that seem interesting? Data sets. It's cool. If you put that up, I appreciate it. Okay, let's see. Uninstalled Hugging Face headlight. What? No, I'm just waiting for you. Okay, let's see. Oh, I'm tell where it is. No, it's going to pick it up from here. Maybe it's the dot notation that's like absolutely hammering this out. I need to change it. It's in that complex. Export. It's the same error. I think it's done what's going on here. This stuff is like sort of a pain to use. Hmm. This is taking too long. There is some issue that it does not like about this auto model sequence transformers, and like these libraries don't get on with each other. And it's funny that I wanted this to be about to learn more about C++, and we're like stuck with like Python implementation issues. Wow. Get it blocked. What you're blocked by. They're just gonna keep trying. I'm just gonna keep trying. How long is this gonna last? Why don't you just ask me to do it? So rerun it and you'll be fine. Um, okay, so it's gonna get this. Let's go ask GPT-5. Hey, come on. Why didn't it recommend to do this? That's the inference. I think. Okay, so it's going to get these little things. Okay. I assume this. this in a place. So got the file show. Yeah. All right. So it's got these, and then now we should be able to run inference on it. I want to know if it's like faster or not. Is this faster on PyTorch? So basically, like it did some work to like take the data. Wow. So the classification is faster than us. So for your current setup, CPU only PyTorch as it versus a tiny GPU kernel. Break it down. Read the features from the disk, copy the weights, launch one small kernel to do matrix multiplication, capitalization, print. PyTorch CPU uses everything in memory. No GPU transfers, Python overhead. Wow. PyTorch is faster. That's crazy. Let's go. Let's compare it. Bench. Oh, I got like, where are we at? Okay. Probably should be used in Python, really, because it's more general purpose. But if you need like a lot of control, you probably go with C++. Let's run this quickly and then we can be done. We'll end a lot. Just do this. Okay. Thanks for so long. All right, I think we're over on that time limit, to say the least. Let's see if we can just get this bench working and see. We'll wrap it up. Hmm. 26 26, 27. How long was that thing that I ran that? This ran for, no, where's the soccer one? All right, we got that. That was sort of interesting. It was like interesting to like write some C++, which I've not done probably in a long time. So that was kind of interesting. I learned a little bit about sort of the complexities, I would say. So we went through like some examples today where we took some data from, or we started out just with some like hello, and then we sort of built it up. We did some linear regression. We did some predictions on house prices, football scores, and then we went and did some inference too. So we like looked at the inference and did some work just to like see what inference would look like with Distilbert, is that how you pronounce it? With a data set that produces like positive and negative sentiment, I think. It was sort of interesting because I think that on the Python side, like it's more generalized. So Python was actually more performant than C++ for this use case, but I could see how like C++ just gives you more control. Yeah, I think it would be useful to go back through do some more things with PyTorch. So maybe we'll re-implement more of that. Yeah. All right, with that.